We have learned a lot so far. Joins are a crux of any good query that spans across your database, and you're going to be using it very, very, very often. Now, for visualizations of data, joins become very important. But what if you wanted to run analytical data? Well, Mo, you taught us that there's some average count. We can pretty much make anything of our data. And that's true. But what if I were to ask you the question, what if you wanted to do that on department basis? What if you wanted to group your data into logical groups, let's say by department, by salary category, by gender? There's all different types of ways of grouping data. And I'm alluding to something here. There's a keyword, a new one we're learning, and we're going to supercharge our knowledge of SQL with this one. This is going to be something that unlocks so many avenues for us. Group by. Group by is a keyword that is used to summarize or aggregate data by groups. Grouping data into logical buckets allows us to operate against those buckets individually. Now, the question is, why would you group data? And the answer is to get in-depth information by group. We want to get that in-depth knowledge, that specific information by that group. Again, for instance, by department, the salaries by department, or the amount of employees by department, or the total amount of salaries paid by department. There are many different avenues we can walk that a business manager would come up to you and say, hey, I really need to know this thing. I really need to know it by department or by start date, like grouping them by like year of start. When did we hire the most expensive employees, etc., etc. There are many different questions that you can answer when needing to group data. So what if we wanted to know how many employees worked in each department? That's the question we've been alluding to this entire time. What if we wanted to know that? How would we do that? Well, that's a big question mark, right? Like, it's confusing. We haven't seen this group by thing yet. How does it work? What does it look like? Well, right now, how we would think of it in our head, the mental model, you would be like, hey, Mo, I'm just going to select the department number, and then I'm going to count the employee number from department employee. Then I know how many employees are by the department, right? Let's try that out. So if I were to say select department number, count employee number, and we did that from department employee, well, let's see what happens. It explodes right in our face. And the error is column department number must appear in a group by clause or be used in an aggregate function. What? Okay, well, let's go back to our slides real quick. Now, didn't we learn that sum, min, max, count, etc. return one record? They like aggregate data, right? So if they're returning one record, what's the group by for? Why is it complaining about this group by? Well, as you could see by the error, it's telling us, hey, if you want to do this, you need to group this data by this column. So group by splits data into groups or chunks so we can apply functions against a group rather than the entire table. Now let's take a look at what that looks like. So over here, we're back at our error. And it's saying, hey, department number must appear in a group by clause. And we learned that count, sum, min, max, they return one record. So when we run this, okay, we're getting the total amount of employees. We know how many employees work for the company. But now we want to know by department. And when we execute this, it blows up in our face, right? Now, if we followed what it said, group by, and we said department number. Okay. I follow. The group by is this new keyword that we're putting at the bottom. And it's going to group the data into chunks by department number. So every department is going to become a group. So it's going to go look at every single group. So let's select department number, for instance, and let's just quickly comment this out. We look at this and we know that, okay, we have D5, D7. Let's quickly order this because order by department number. And so what we can see here is a lot of employees work for Department 1, Department 5, Department 7, because this is department employees, remember? We're getting a record of each department number per employee. So if we group these by department number, what we're going to see is that, okay, we're getting groups. So D1, D2, D3. Interesting. So it grouped the data. It took every single department and it grouped it by the department number. So every single employee that was in Department 1 is now in this logical group, right? Think about it this way. What we basically did is we said, hey, group it by the department number. So every time I find D001, which is unique, just put that record in that bucket. And so what do I mean by put that record in that bucket? Well, now, if we said employee number, what's going to happen is it's going to complain to us. It's going to say, hey, you grouped by department number. What are you trying to do here? This is your group. This doesn't belong to your group. You can't just go ahead and say visualize this because our groups are by department number. Now, if I added employee number to this, what we're going to see is that now the group is by department number and employee number. So it's not really going to be very granular anymore. We're going to get all of those D1s again and D2s again, and we're going to see every employee number. So our group now explodes back out to what it originally is. That's not what we want to do. When we have this logical group and this explodes, what we're basically doing here, and what is the power of group by, is when we create these groups, the purpose of it is to run functions against some other part of the data. We want to run a function. So if we said, hey, count this. Well, if we count employee number, now we suddenly know, hey, how many employees are in each department? How many? And now we suddenly know this. We know that 20,000 employees are in Department 1, 17,000 are in Department 2, etc., etc., etc. So group by splits data into groups or chunks so we can apply functions against the group rather than the entire table. Because as you remember, when we ran functions, we were running functions to get a single answer, a single return value. If we counted employee number, we get the total number of employee numbers. So group by allows us to chunk the data into groups so we can apply the function against a group. We use group by exclusively or almost exclusively with the aggregate functions with sum, min, max, count, etc., etc. Now, why? Because when we get a group of data, we often want to know something about that group. And that something we want to know is most likely a count, a sum, a min, a max. Whatever the case is, you wanted to know the highest salary in that group, you wanted to know the amount of employees in that group. There's many questions you can ask here. When we group by, we apply the function per group. This is very important conceptually to remember. When we group by, we apply the function per group, not the entire data set. So remember, when we used to apply sum, min, max, count, it was against the entire data table. It was against every single row. But when we group by, we're applying the function against that group, the group by department number, for instance. So this was our answer. Select department number, count employee number, and we're grouping by the department number. We're creating those logical groups, those unique groups. Group by is stricter than it looks. You have to remember this. Now, we just saw how powerful this can be. We just saw, hey, I can group stuff. But there's some things that we need to remember, and that is that group by is stricter than it looks. Every column not in the group by clause must apply a function. And that's what we saw when we did comma employee number. It exploded in our face, right? Let's take a look at that again. When we went over here and we didn't apply this count, oh boy, was it mad. Column employee number must appear in the group by clause or be used by an aggregate function. So it's telling us what to do. It's telling us specifically what we should be doing with this. Errors are always useful like this. So It's telling us, hey, either put this in your group by or apply a function to it. Group by is stricter than it looks. Now, why? Well, group by is there to reduce all records found for the matching group to a single record. So when we create this group, it's going to boil that group down to a single record. It's to run that analytical and aggregate function against that group. What we basically are saying is, hey, we have all of this data and there are all these kinds of duplicates in here. And I want to run this calculation against this group. I want to know an output for this group. So it's going to boil down the group to a single record. And we can run analytical functions against different parts of it. We can say, hey, count the amount of employees. Get me the max salary number. Anything you want to show after the group has to boil down to one record. Anything after department number, for instance, like we saw, either has to use an aggregate function to boil itself down to one result, to a singular result, or it needs to become part of the grouping. It has to create that new unique group. So you may be asking yourself, okay, well, how does this group by work? Because we're creating these groups, but what's actually happening here? Well, group by utilizes something called a split, apply, combine strategy. It's going to split, apply, and combine. So let's take a look at that. Split, apply, and combine looks something like this. You have a data set of records, and we have 2 A's, 2 B's, 2 C's. And we're saying, hey, the groups are by X. So if we're grouping by X, we're going to split out X, the unique groups of X. So A, B, and C. So now that we know the unique groups, well then we're going to apply something to it. So we apply an aggregate function to Y. That's what we're doing. So we split out the groups A, B, B, C, C. We apply some kind of aggregate function to Y. And then we combine the outputs to get the groups with the singular output. A equals 3, B equals 2.5, C equals 7.5. Split, apply, combine. We split by the groups, we apply the aggregate functions to the remaining columns, to the columns we specified that need to apply an aggregate function, and then we combine the results to gain the output. So, split, divide into groups with values, apply. Apply aggregate against ungrouped columns, the ones that we specify. The combine phase combines groups with a single value into a single value. Now, what does this one mean? Well, the combine phase is going to say, hey, I have this group A, I have this group B, I have this group C, and I have all of these things I applied an aggregate function to that also outputted a single value. And now I'm going to visualize group value, group value, group value. Kind of like we saw over here. Group value, group value, group value. And the value is a single output of Y. The group is a single value of X. So, earlier in the course, we looked at the order of operations. And the order of operations is the order in which SQL does something. And what we can see here is that we're doing from, where, group by, select, and then at the end we order data. So, something to note here is group by came in the middle. What just happened here? Well, group by happens after the where clause and the from clause. So if you have a where clause, the group by has to come after it. If you don't have a where clause, it has to come after the from clause. And then if we look at what happens after you do the groups, that's when we do our select. And that's when we do our ordering. So the order of operations is important to know because you need to know where to put your group by clause. If you accidentally put it before your where, well then weird things are going to happen. It's going to complain to you. It's going to say, hey, this needs to come after. And so with all of that said, let's jump into some exercises that we can do around group by to flex those muscles. What if I want to filter on groups? I can hear you asking yourself, hey, Mo, I saw in that visualization that the order of operations, the group by, happens after the where. So how would I end up filtering on the groups. How does that work? Well, there's a keyword called having, and that keyword is used after group by. So if we looked over here, we can see from, where, group by, which we just recently learned splits data into groups to apply functions to. And then we have the having keyword that happens right after. And if we look over here, we can say select column 1, count column 2 from table. And the where clause is still applicable. You can still use the where clause. You can say where column 2 greater than x, etc., etc., etc. And then with the having clause, you can apply filters against the group. Now, over here, you can see I just did a simple column is equal to y to illustrate that having kind of acts like a where clause. It does. It's kind of similar, but where applies filters to individual rows. So when we go through the data, when we're visualizing in our head, hey, how does this query work? When we do the where clause, the where applies filters against each individual row when it's going through the data, and having applies filters against the groups as a whole. But not only the groups as a whole, when we apply aggregate functions against a group, the having clause can filter against the output of that aggregate function. Now let's take a look at that more in depth. Now over here, you can see I wrote a bit more elaborate of a query because we're not walking into simple territory anymore. No. We're becoming SQL masters. We're masters of the query. So when we look at this query, what we're trying to do is select the department name, and then we're counting the employee number. So we want to know the amount of employees in a specific department. And as you can see by the output here, we know that in customer service, 23,000 people work, in development, 85,000, and so forward and so forth. And this is a bit more of a complicated query because we know that in the employee table, we don't know the department name. So we're doing two joins here. We're joining by department employee and we're joining by departments. And we're doing it on the employee number and the department number. So we're getting the department by employee. Now, that being said, we are grouping by the department name. Those are our logical groups. That is the individual group by which I want to know how many employees there are. There is no other group that would be logical here. Maybe you could group by department ID as well. If you add that to the group, you still maintain the logical group. If I said, hey, d.department number, well, then it's going to complain to me, obviously, because I have to put it in here. But you will see that nothing actually changes to the logical groups that I have. It's just I get more elaborate information. And the outputs remain the same. The calculation remains the same. So when you formulate groups, there may be multiple records that you can do this against. So with that, we have our output and we know how many people work in each department. But now, we said that the where clause and the having clause kind of work the same. So let's say I wanted to know how many female employees I had in each department. And I wanted to know only the departments that have over 25,000 employees. Because we can see here that, hey, not every department has X amount of employees. So let's say we unfiltered this. Well, right now we're going to say, hey, which departments have over 25,000 employees? Okay, great. These many. What if I put this in the where clause though? What would happen? That's a good question. So let's check that out. If I took the where clause and I put the count in here, well, what's going to happen is aggregate functions are not allowed in the where. Interesting. So this isn't going to work. And the having clause actually exists because of this exact reason. Its entire purpose is to filter against the groups. And it is allowed to use aggregate functions because it wants to filter against the singular output of that group. So when we use having, we can do the exact same aggregate function that we do in our select, and we can filter against the specifics of the aggregate function, the aggregate output we're trying to get. So now we know, hey, which departments have over 25,000 employees? But the where clause is still valid. You can still use it. You can say, hey, only get me the departments over 25,000 employees where they're mostly female employees. And as we can see, we're getting development and production, and we can see how many people work in both those departments. Now, what if I put this inside of the having clause? What would happen? Well, not much. It's just going to apply it against the group instead of against each individual field. And it's going to say e.gender must appear in the group by clause or an aggregate function. So you're not just allowed to use having to do the filter with the where. If you're going to do this, then it needs to be logically by group. And then what we can see here is 34,258 and 29,549. So what if we did this in the where clause again? Do we get the same output? Remember that number, 34,258. So if we said where here, well, we get the same exact output. Now, the difference between where and having is that when you use having, if you're going to apply a filter against a regular field, well, then it has to appear in your group by clause. So again, having applies against the groups, where applies against each individual record. So there are cases in which you can have a where and a having in the same exact query. And again, we have our inner joins here as well. So we can build very complex queries where we're filtering groups and doing all of these things and creating a very complex scenario to get a very simple output. How many employees that are female work in this department? How many employees that are male work in this department? And so we can kind of figure out, based on this query, some more analytical information about the company. We can figure out, hey, I want to know this about the company, or I want to know that about the company. So group by and having are very powerful tools to get very specific filtered answers. Now, with that said, let's go jump into some exercises around having. One thing we haven't looked at yet is sorting with grouped data. So over here, we have our query where we were selecting the amount of employees by department. And we were specifically filtering on departments with over 25,000 employees, but let's not do that for now. Now, according to the order of operations, order by should come after group by. It should happen after, right? So with that said, if we did order by over here, we could order by the department name. And if we order by department name, what we can see here is that we're getting it alphabetically sorted by department name. Or we can sort by the count of e.employee number. And we can sort that ascending or descending. So when we do that, what we can see is we're now getting the ascending or descending order of the amount of employees that we have. So there are many different ways to utilize the order by, but you can order by the groups that you've made. So with that said, we can use the order by to run against our analytical functions that we've applied, right? To get some semblance of, hey, here's the highest, here's the lowest type of thing. Just always remember that order by happens all the way at the end. But you can use your analytical functions in the order by to order by the output of it. In the previous video, we saw everything about group by. And so before we dive deeply into the exercises and the ins and outs of working with group by, I kind of wanted to show you how to work with it and what kind of questions we can answer and where some of the limitations are. Because at the end of the day, what we're trying to do with SQL is navigate our data. We want to find answers to questions that can be asked by either the business, yourself, or others. Questions are central to the outcome of what we're trying to get. And so let's say I ask the question, hey, get me the most recent date that they got a salary bump. How would we go about that? Let's try to type it out. So if we did select, and we selected the employee number, comma, the salary, and we did that from the salaries table. So we have the employee number and we have their salary. The next thing we need to do is we need to get the from date. So with this, what do we know? Well, with this, we'll know their number, their salary, and the from date. And if we scroll down, we can see that the latest date for 10,001 was 2002. Knowing that, we can kind of now formulate roughly what our response should look like. And for 10,002, it should be 2001, and so forth and so forward. So knowing that, we can now go ahead and we can say, all right, I know how I want to group my data. So let's group by employee number, and then let's say salary. All right. And knowing that, we can then say, well, get me the max from date. What is this going to do? Well, let's see. Well, logically, when we group this way, we have to think about it in a way that kind of makes sense. So we're grouping by employee number and salary, meaning that our group is going to contain these two columns, which means that a group consists of a unique value, the employee number, but also the salary. And each salary is unique. You may come across a case where they may have switched roles and had the same exact salary, but most cases your salary is going to go forward or go backwards depending on. So should we be grouping by salary? I think we shouldn't. So let's remove that. Okay. So knowing that now, we can remove it there and remove it there. And let's execute that. Okay. So we're now seeing what we wanted to see. 2002, 2001, 2001. So we know at what date their latest and greatest salary bump was. And now if I were to ask you, well, how do I get the salary that correlates to that, right? Let's go ahead and look at what the data actually looks like. So over here, I made 3 different tables. The red background here symbolizes a grouping. So if I did employee number, first name, last name, and then I wanted to add the from date, well, what you can see here is that each logical group will consist of these columns. So this is a group. And then what we can see is that our from date actually has multiple values. 1990, 2002, etc., etc. So when we get the from date out of this, we can use max. What we end up doing here is determining the maximum of from date. And so when we do this, what we're basically going to get is this value. Now, if we go over here, here's the second part of this. What we know is that when we do groupings, groupings have to be unique. So if we added from date to our grouping and we had employee number, first name, last name, and from date in a group, each and every single group is going to be a single row. That's not what we want. How are we going to determine the max based off of this? Because each group only contains one. Well, you could do the max based off of the total table, but the whole point of groupings is that we get the maximum from that group. So putting everything inside of the group by doesn't help. Let's look at that. We kind of saw it by putting salary in, but let's see what happens when we put from date there. So if we put from date here, well, then we know we can't run the analytical function because it's going to explode. Each group has to be unique. Because if I put max now around the from date, what you're actually going to see is that the maximum is just going to be the date that's in the group. There's only one date in the group, right? Each group is a singular line, right? So there is no actual grouping data. That is why grouping like this is so important, because you can see that we have 2 records. But if we go down here, And let's say we still grouped by the same data, but now we wanted to know with the from date and the salary, okay, we have groups. So let's check out how that would work. So if we did max salary, what's going to happen here? We know we have the right max from date based on us only grouping by employee number. We definitely have the right max date, 2002, 2001, etc., etc. But when we do max salary, okay, let's see, 2002, 88,859. Well, let's see what that looks like. And if we go look at their salary in 2002, it was 88,859. So this is correct. And most of these are probably correct because getting the max salary, assuming that their salary only progresses forward, you can make a reasonable assumption that getting the max from date and the max salary, they're going to correlate. But how can we be certain that this relationship is actually correct? Well, we know now that with group by, we can get the right analytical data from the aggregate function from the from date. And if we just got the max salary, we're reasonably sure we're going to get their maximum salary throughout their career at the company. But we cannot know that this and this are related to each other. Let me explain why. So if we go down here and we look, what we can see here is we are grouping by employee number, first name, last name. And so we have these logical groups in time, 1880, 2002, 1880, 2000, 1880, 1980. I kept saying 1880, it's 1980. So with these groups, what we can see is that we have a salary. Now, assuming that salary progresses forward, we have 88,000 and 99,000 in 2002. But if we look at employee number 3, what we can see is that they actually went from making 90,000 to making 70,000. So in this case, if we ran the max against salary, but they got a salary decrease, well, now we're not going to know for certain if we got the right salary. And we learned so much about filtering. So you may be asking yourself, Mo, can I just apply a where clause or a having against the maximum salary or whatnot? Technically, you can't. Let's see what that looks like. If we go back over to our query and we look at it, well, if we just do this, we are fairly certain we have the most recent date. But what am I going to put in my having? Am I going to put having a max from date? Max from date related to what? What we actually want to do is we want to take the outcome of this and apply a filter in a different query. But we don't really have the tools to do this yet. We have the right answer here, but we can't reasonably relate the outcome of the date to the salary in the same query. And this is where it becomes tricky, right? So with group by, we have the ability to get a singular outcome. But when we want to relate that to the salary, well, this is where the question becomes difficult. And so there are different techniques of doing this, taking this data and applying it against a different query, or using this in some kind of way to retrieve that answer based on your from date. For now, we don't have the tools just yet to do this. But what we do have is the ability to understand how groupings work. Because if we look here, what we understand is that each logical grouping is making data available for running analytics against. We can reasonably say that we can get the most recent date that they got paid their latest salary. Or we can get their highest salary in time. But we can't yet determine what is the salary to the date in the same query. So with that said, what I want to give you here is that visualization of how group by works, how the data looks when you actually apply the groupings against the data, right? Knowing that we're getting this, we can obviously run our aggregate functions to get some kind of answer, but we can't run our aggregate functions to relate two columns of data to each other in the same exact query. And so we will be learning tools around doing this. But for now, what you have to understand is this mental model of grouping data and drawing something out of it, drawing an answer out of it. Because at the end of the day, what we're doing is we're getting data, we're getting a structure of data, we're drawing a conclusion out of it, and with that conclusion, we now have an answer, or we can do something else later on. The mental model of group by, the mental model of groupings, is what we need to take with us. And we also have to understand the shortcomings of group by. Because we can grab an answer out of it, doesn't mean we can do everything in a singular query. There are limitations to what we can do in a single query, but there will be techniques and ways that we will learn down the line of how to reuse that and chain it on to do other things, right? Once we get an answer from a query, once we get data back, we can take that data and do other things. We just don't have those techniques yet. So keep in mind that we have to learn this mental model of grouping and retrieving data back. We want to understand how data works, right? We want to understand that when we get a result, that result, that subset of data that we're getting back, we can reuse later on. In the previous video, we saw how group by can trick you into a false sense of, well, if I have groupings, then I can obviously calculate a result out of it. And grouping, although a very powerful tool, still has limitations. There are still questions we can't answer, and that was the purpose of that video. The purpose of this video, however, is to ask you a question. What if we want to combine the results of multiple groupings? Now, you can kind of feel that we're picking up the pace here. We're going faster and faster, and we're learning more complex things as we go along. And the reason for this is to master SQL, hard questions need to be solved. And to answer hard questions, we need to accelerate the pace. So with the previous video, we were showing you, okay, we know how groupings work, and we know how we can get answers out of groupings, but groupings have limitations. And in this video, what we want to show you is, hey, if we have groupings, how can we combine multiple answers from different groups? Now, before we dive deeply into it, there's this thing that I want to show you, this thing that we haven't seen yet, combining multiple results from multiple selects. Now, I hear you thinking, Mo, what are you talking about? We can only run one select statement at a time. And yes, that is true. We have done that up until now. And when you run one select statement, you'll get one subset of answers. But the thing about SQL is, we're working with data. We're getting data sets back. And when we get data sets back, we can combine those data sets. We can combine the results of multiple selects into an output. Now, it really depends on what you're trying to answer, if it may or may not be valuable to you, because over here you can see union. And what union does is, if we look at the query down here, we're selecting column 1 and we're doing sum of column 2 from a table, and we're grouping by column 1. Very simple group statement where it really becomes obvious that what we're trying to do is get a result here out of a grouping, for instance, like we did with the departments. Now, if we did a union and we did select sum of column 2 from the table, we'll get the total sum of all the records, right? Because the aggregate function will get us the total amount of column 2, not by the grouping. Now, what this union is going to do is it's going to take the result from this, and it's going to take the result from this, and it's going to merge them so that you can see this result inside of the same data set. Union is one of those powerful things where if you want to run multiple queries and combine the results into one table, it can help you do that. And on top of that, there is a separate keyword called union all. Now, what's the difference, I hear you ask? What's the difference between union and union all? Well, the main difference is that union all does not remove duplicate records. Remember when we said that SQL and tables cannot contain duplicate records, and that the primary key is there to warrant that we have unique outputs? Well, union is going to remove duplicate records. It's going to make sure that the data set we get back does not have duplicates. But sometimes you may come into a case where you do want those duplicates. So union all can be used so that you don't remove those duplicates. It's one of those cases where there's different ways of working with data and combining data, and the push and pull of whether or not you should use it depends on the question you're trying to answer. Now let's look at a case where we would use union. So over here, what we can see is that I have a query. And this query is selecting null as prod ID, comma, sum of order lines quantity. So we're going into order lines. We're in our store database and we're going into all of the different orders that have happened. So we're selecting the total quantity of things we've sold, which we can see here is 120,719. So we know we've sold a total quantity of products that equates to that amount. And then we do a union. So we're combining data sets. And then we say select prod ID, as prod ID, and you want to use the as because if you combine unions, if you don't use the as, it will not give the record, the column a name, and the order by will break. So you can see here, it won't give the column a name. So it's important to use the as to give the column a name. Now we can see here we're doing a grouping by product ID and we're seeing the sum of the quantity we sold by that product ID. And then we're ordering it descending. So what we can see here is that when we run this, what we are doing is for product ID 1000 we sold 9, and if we go all the way down, we can see that for product 1 we sold 9 items and so forth and so forward. And we can see the total amount per product that we sold, and we can even go ahead and filter on that if we need to. But the important part here is that we have a combination. We've combined records. And if we did union all, of course, it would not remove the duplicates. Now, in this case, we do not have duplicates, but there are cases in which you could have duplicates, especially if I were to do something similar to here, but with a different calculation. Now, the whole point of this is to talk about what if I want to do this in one query? What if I want to show the results of multiple groupings in one query? Well, that's a good question. And so if we were to look at that, we have our group by statement. And over here, we were saying, hey, I want to see the grouping of product IDs. I want to see the sum, the total quantity of all of the product IDs I've sold. And here I'm saying per product ID, I want to see the sum of the quantity that I've sold. Now, if we wanted to combine those into one query, SQL gives us a cool feature called grouping sets. And what grouping sets allow you to do is it allows you to combine the outputs of multiple groupings, kind of like the union would do. So if we were to do a grouping set of nothing, and then a grouping set of prod ID, well, what would we get? So if we execute that, we can immediately see we're getting the same exact result. So this is just another way of writing this union syntax. And we get the same exact output, because if I remove the order by, then you can still see that the union is happening. So what's important to note here is that grouping sets work the exact same way as a union would. And it's a powerful tool when you want to combine the output of multiple things. Here I can see the total sum of the quantities I've sold, and here I can see them by product ID. And I can go further and I can do it on different things. I could do it based on the order line ID. I could add that as a third grouping. And in that case, we can see that we are indeed grouping 3 times. And certain values are null. Interesting. So if we went ahead here and we did order by prod ID, we could clearly see what is happening here. 1, 2, 3, 4, 5, 6, 7. And so let's add the order line ID. And let's execute it again. So over here we can see that certain order line IDs have a sum. So we're combining the data sets. And over here you can see that this is the total amount of quantity we've sold. So if we order it by prod ID and then order line ID, then we can see that our total sum is all the way down. Now, if we did this descending and we did this one descending, it would end up at the top. And there we go. This is the total sum we've sold. This is the sum per order line ID. And this is the sum per product. And what's useful about this is we can clearly see different groupings and different outputs in a very easy way. We're grouping and creating a sum based on different grouping criteria. And that makes it easy to put it all in one query rather than have to write a union of multiple queries, which is super useful. And that is what grouping sets are for. Grouping sets is a subclause of group by that allows you to define multiple groupings. Let's remember that. And now let's do some exercises on it. Grouping data is one of those cruxes that can become more and more difficult as we go along. We just looked at grouping sets. And here I have another query for you. So let's run through it. We have a select. And what we are selecting is the extraction of the year, the extraction of the month, and the extraction of the day. And then we're doing a sum of order line quantities. So we're trying to figure out, hey, how much was sold on the year, month, and day available? But now comes the interesting part. What if I wanted to know, hey, how much did I sell on each day? And then how much did I sell on each month? And then how much did I sell on each year? And I want it to be a progressive set, right? So meaning I want to know each individual day by year and month. And then I want to know each individual month by year. And then I want to know each individual year, the total quantity that was sold. So I want to have all that data. So we looked at grouping sets. And grouping sets are perfect for this because we're saying, hey, run multiple groupings. And what we're trying to do here is group by year, year and month, and then year, month, and day. So that's perfect, right? If you look over here, what we're trying to do is we're trying to extract in the grouping set. We're trying to do it by year. And then we're trying to do it by year and month. And then over here, we're trying to do it by year, month, and day, which is amazing. And then if we scroll down here a bit, what we're trying to do is we're trying to do it by month and day, by month, and then by day. And then, hey, what was the total? So this last one is trying to tell us, hey, what is the total amount that we sold across all time? And so we're ordering it by year, month, and day. So what is the output of this query? Well, let's see. So if we look here, what we can see is we're in 2004, on the first month, the first day, we sold 329, and so forth and so forward. And if we scroll down, eventually we're going to hit the end of the month. And this is the total we sold for January. Amazing. And then if we go to the second month, we can see that, we sold a total of 10,075 for the month of February in 2004. And so forward and so forward. And then if we go towards the bottom, what we're going to end up seeing is instead of a monthly view and a daily view, we're going to see a yearly view and a daily view. So on the first day of the month, no year, we sold a total of 3,967. So on the first day of all the months combined. On the second day of all the months combined, it's 3,754. So we're obviously grouping this data by month, year, and date, which is great. And here is the total we sold across all time. So by grouping all of this data this way, what we basically have now is the ability to look at our data in a way that shows us multiple different types of groups. And by knowing this, what we can do is kind of build up those different groups together. Now, you can kind of see here that this is a lot of work. We have to type out all of the different groupings that we want. Well, there's an easier way to do this, and it's called rollup. And what rollup does is it will take a group and it will make all of the extractions for you. up until this point right here, up until this point. So it's going to basically say, hey, this is the group you're giving me to roll up. So what I'm going to do is I'm going to do it by month, day, and year. Then I'm going to do it by year, month. Then I'm going to do it by year, and so forward and so forth. It's going to basically make all of those combinations up until nothing. It's doing the same thing we did with our grouping sets by making all of those different combinations. And I didn't even make all of the different combinations in the grouping set because it would take a lot of code. But what rollup does is it's going to take, hey, these three things, and it's going to make every possible combination between these three things. And so if we execute that, then what we're going to see here is that we have year, month, day like we did, and so forward. And then we have it by year and month. So in January of 2004, so forward for every month throughout the year. And then at the end, we have the total for 2004 by year. We have the total for 2004 by month, and we have the total for 2004 by days. So we created the same exact thing. And it even went so far that it sorted it for us because we used our order by properly. So again, we have the total for all time. We have the total for every year. Looks like we only sold in 2004 in this store. Went out of business after that. But the thing to note here is that it created all of these different groupings. So we have it by year, we have the all time, we have it by month, and we have it by individual days. And that is the interesting part here, is that it rolled up. That's why it's called roll up. It dynamically creates these different groupings for you. So let's take a second look at that. So we're basically doing an extraction by year, month, and day. And so it's rolling up. It's doing all three, then it's doing two, and then it's doing one, and then it's doing what we knew to be none. So it goes all the way up to nothing, which is the grouping of all time, correct? The sum of the quantity sold all time. So rollup is useful when you have grouping sets that need all of the possible combinations between all of the values. It's an easier way to write it than writing all of the possible grouping sets, because writing all of the possible grouping sets is pretty error prone. You have to think about every possible group. Rollup is a useful command. How often will you see it in practice? Probably not super often, depending on what you're trying to accomplish or what kind of question is being asked. In this particular case, this is a good question. It's, hey, how much quantity did we sell across these 3 dates? You will see it in practice depending on what industry you work in. So it can be a useful little tool to clean up your queries.